Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello students, let us solve the next question, number 23 of NEET Physics paper 2017. Hello students, let us solve the next question, which is number 23. The spring of force constant K, this is spring of force constant K is cut into length of the ratios of 1:2:3. So this is cut into 1:2:3 parts, 1:2:3 parts. They are connected in series. So, and the new force constant is K dash, and they are connected in parallel, and force constant is K double dash. What is the ratio of this K dash over K double dash? We know that if in case of spring, in case of a spring, the spring constant is inversely proportional to the length of the spring. That means K is inversely proportional to L. Lower the value, higher the value of K. So, and the ratios are in the 1:2:3. Suppose this part is having because when you cut this in different lengths, because different lengths means different K. So this part 1 will have different K because different length. This one is suppose having length K is suppose K1 here. This part of the spring, which is two parts of the total value. Here the stiffness constant is K2 and here the stiffness constant is K3. Then if these are the individual K's for when they are cut into this ratio 1:2:3, and they are connected in series, when we assume that there are such different types of springs connected in series, then I should get K, because this is the same spring. If you disconnect them and connect them together, then also you get the K again. So this K prime which is required should be K. This is a new effective resistance, effective spring constant, which should be K. But still we will find that. And then these three parts are connected in parallel. So when they are connected in parallel, it will look like this. First part, and the second part is a little more length, and third part is a little more length. Now these three are connected in parallel, and put some load here, then this is K1 and this is K2 and this is K3 spring constants in parallel. So in this situation, the effective value of K of this combination is K double prime. In this situation, when they are added, the effective stiffness constant is K prime. So our aim is to find K dash is to K double dash. So I will just have to find the series combination of springs of springs. Now K is inversely proportional to L. That means K into L is a constant quantity. The total length I'll write here. It should be, if I want to find K1, K2 and K3, they are in the ratios of what I have to find. The lengths are in the ratio of L1 is to L2 is to L3 equals to 1 is to 2 is to 3. So if I think that the total length is 6, then K into L is constant. So this I'll write this as reciprocal. The ratio of the lengths is the ratio of reciprocals of these values. So it will be K1. I'll write this is total value is how much? 6. So 1 over 6. So K1 will become 6 times K. Okay. Because out of this 6, one part is there. So K dash, because the length is reciprocal, so the length is 1 over 6. Length is 1 over 6. So length ratio is 1 over 6. So K ratio will be 6 times, because reciprocal, 6 times K. Similarly, K2 will be how much? Is proportional to 1 upon L2. And what is L2? L2 is 2 parts of 6, that is 1/3. So if L is 1/3, then K will be 3 times. So it is 3K. Similarly, what about K3? K3 is inversely proportional to L3. But L3 is how much part? L3 is 3 part out of 6, that is half. If L3 is half, then K2 will be double. So it is 2K. So these are the spring constants it will become. The higher the length, the longer the length, the smaller the value of K, spring constants. This is having a very high length of 3 parts, so its stiffness constant is very less. Now, in case of a series combination of springs, as we have seen here, the formula for K effective, that is K prime, is 1 over K1 plus 1 over K2 plus 1 over K3. So if I solve this one, I put these values over here. 1 over 6K plus 1 over 3K plus 1 over 2K. So from here I take 632. So I will take LCM. So I will do one thing, I will make everything 6 here without LCM also. 3 multiply here, 3 divide here, 2 multiply here, 2 here, so it becomes 6 and nothing is multiplied here. So this will become 1 plus 2 is multiplied here and there, so it becomes 2, and 3 is multiplied here and there, so it becomes 3 divided by 6K. That is fine. That is my 1 over K prime. This is 5 and 6, so 6 over this. So what I'm getting is that 6 divided by 6K is 1 over K prime. This is what I'm getting. So from here 6 cancels, 1 by K is 1 by K prime. So K prime is K, which is, I told you in the beginning that if you cut the same spring in different parts, different lengths, and then connect them in series, obviously you are getting the same original spring. So the stiffness constant earlier was K, so now also it will become K. This is my equation number 1. Then I move to the parallel combinations. So when these springs are connected like this, then what will happen to K double prime? In parallel combination of springs, we use the formula for K effective in this case is equal to the sum. Just add them together algebraically. This is 6K, this is 3K, this is 2K. So K double prime is 9, 11K. This is equation number 2. So our question is to find the ratio of K dash over K double dash. So K dash over K double dash can be obtained. K value is K here and K double dash is 11K here. This K will cancel and this becomes 1 over 11. So K dash is to K double dash is equal to 1 is to 11. This should be the answer to this question. 1 is to 11 is option number 3. So that is the correct answer to this question. Okay, thank you.